Okay, Year 11, about to start our new unit on trigonometry. The first couple of chapters are a couple of exercises are just revision. I like the way that this textbook starts it though, and it starts it with similar triangles, which is what trigonometry is. So here you can see three examples of right angle triangles with an angle of 30 degrees. Now, what you need to know is that if there is an angle of 30 degrees in this triangle, in their right angle triangle, then the other angle has to be 60. And that'll be the case here, and that'll be the case here. And because all the angles are the same, these three shapes are similar. Now, the beauty of similarity means that the sides are in ratio. So all these shapes are just bigger or smaller versions of each other. And as you can see, it's in a ratio of 1 to 2. So it keeps getting bigger, but the angles don't change. Remember that the angles don't change. But what is preserved is the ratio of each of these sides. And what they're talking about here is this on this. That side to that side is 1 to 2. That side to that side is 2 to 4, which simplifies to 1 to 2. This side to this side is 3 to 6, which simplifies to 1 to 2. And it doesn't matter how big or how small your triangle gets, the ratio of that side to that long side is always going to be 1 to 2. Now, to try and use this then, you had to define each side. And we know that depending upon where the angle is, we can define the side by that angle. So it's pretty easy. The hypotenuse is always the longest side. It doesn't matter how you stitch it up. It will always be the longest side. We already know that by Pythagoras. But the opposite and the adjacent are all reliant upon where this angle is. So if this angle is there, well, that side is the opposite and this side is the adjacent. But if we're talking about this angle, well, then that side is the opposite and this side is the adjacent. And if you conquer that, trigonometry is easy. Now, in all right angle triangles, we can define each ratio. Now, how you decide to do this is up to you. But what essentially you're saying is that it doesn't matter, or what we're going to call the opposite over the hypotenuse. What ratio will we call that? Well, they decided to call that sine. And they said the sine of this angle, whatever that angle happens to be, so in this case, 30 degrees, opposite over hypotenuse is 1 to 2. And you can check that. Your calculator has that stored. So if you go sine 30 degrees, you get 0.5, which as a decimal, as a fraction, is 1 to 2. So we're going to define sine in relation to this angle as opposite over hypotenuse. And we're going to define cosine as adjacent over hypotenuse and tangent as opposite over adjacent. Now there are three other ratios. There is the hypotenuse over the opposite, which is just the reciprocal of sine. And we call that cosecant. And then we have hypotenuse, and cosecant theta we should call it, hypotenuse over adjacent, and we call that secant. And adjacent over opposite, which we call cotangent. Now, they don't put these ratios on your calculator because they're just reciprocal. So if you know that sine of 30 is 1 to 2, which we do, well then cosecant of 30 is 2 to 1. It's just the reciprocal. Now, here trigonometry or triangle measure. Trigonometry, the word itself means three-angle measure. Tri means three, gon, angle, and metra means measure. And the Greeks gave us all the terminology. Doesn't mean that they were the first to do it, just means they gave us the terminology. And we know they weren't the first to do it, particularly if you watch that YouTube clip on Plimpton 322. We measure angles at this stage in angles and degrees and minutes and seconds. And you need to know how to do those. That's pretty standard. So in your notes, make sure you have all your right angle terminology. I'd draw a little right angle triangle like I have done here. Call that theta. Call that hypotenuse. Call this adjacent because it's the side beside the angle. And call this opposite. And then I'd write down all my ratios. Now, there are many tricks you can use to try and remember them. Some people say SOHCAHTOA. I remember some old hags can't always hide their old age. But I'm pretty sure, I'm just going to check on my other computer, that you get these in on the formula sheet. So I'm quickly going to check on the reference sheet, and I've got it up now on my other computer. And if I go down to trigonometry, yep, and they write it as op over hypotenuse and add j, ag, adg, the j over hyp, and op over adjacent. They also give you up here, and they say sec is 1 over cos, so just a reciprocal, because that's what that means. And they say cosec is 1 over sine, and they give you cot is cos over sine. And we're going to talk about that in a minute, because we can use tan. Yeah, well, we'll talk about that as we move along. Okay, so most of these questions are pretty easy. Now, writing down the ratios, I'm not going to go through that. Write down the ratios for sine beta, cos beta, tan beta, and so on. What you need to be able to do are ones like in question 4 and this one here, 3. And for some reason, my OneNote has changed that up a bit, because I reckon that's beta. Oh, there we go. And we've got to find the other ones. So I'm going to do 3 and 4. So find the exact ratios. So find the exact ratios. What you have to do is you have to find this distance here first. And to find that distance there, you just use Pythagoras. So you get 5 squared plus 7 squared, and they want exact ratio, so it's just going to be a square root of whatever that is. And 5 squared plus 7 squared, 74. And then you can get the ratios of sine, cos, and tan for that one. And the same thing would happen here, but this time, when you did this one, it'd be 9 squared minus 5 squared, which would give you 81 minus 25. Again, I'm going to use my calculator because I don't want to make a stupid mistake. 9 squared minus 5 squared, you get 56. So therefore, sine, and they've got x there, sine x equals opposite, so root 56 over 9. I'm just checking, yep, that's right. Cosine adjacent, so that's 5 over 9. They were the two values we were given. And tan opposite over adjacent, so root 56 over 9. Not over 9, over 5. Okay. If you get to questions like 5, and I'm going to show you how to do 5 by doing 6, because 5 comes out pretty easy. So if they say, cos theta equals 2 on 3, find the exact values for sine and tan theta. Well, you know that this cos theta represents a right-angled triangle. So you just draw a right-angled triangle, put your 90 degrees in, put theta in either corner, so you can put it here or here. I'm going to put it down here just because it makes it easier. Now, what is cos theta? Cos is adjacent over hypotenuse, so that means that's 2 and that's 3. And all of a sudden, you've got two sides, so you can use Pythagoras to work out this side. 3 squared minus 2 squared, which is 9 minus 4, so I'm going to get root 5. So therefore, tan theta is opposite root 5 over 2. And sine theta is opposite over hypotenuse, which is root 5 over 3. So it's just a case you draw yourself a little triangle. Again, using Pythagoras here and discovering the exact values for 45 degrees. You should know those. How do I know it's 45 degrees? Because I know that's 90, and these are the base angles of an isosceles triangle. These are the base angles of an isosceles triangle, so they must be equal, and because they're equal and there's only 90 left, 90 divided by 2 is 45. So these two angles must be 45 degrees because it's an isosceles triangle, and away you go and you do Pythagoras and you'll work out that that's root 2. Okay, again in question 10, looking at these, making sure you can do that for 60 and 30. I would really like to show you where that comes from. So I will. I'm going to do that now. So it's a good thing to know where it comes from. So first of all, I'll do you've seen, because when you try, and you get given this is on your formula sheet. So to find exact values, draw yourself an isosceles triangle, a right angle isosceles triangle. Go, that must be 45 and that must be 45 because it's isosceles. And you have to decide on a length for these two. Well, we want the simplest version. We want the simplest ratio. So we'll choose 1 and 1. And if I go, square root of 1 squared plus 1 squared, well, that equals 1 plus 1, root 2. And all of a sudden, I can get the values for sine 45, cosine 45, and tan 45. And I get the exact values, and I just go, sine 45, opposite over hypotenuse, 1 on root 2. Cosine of 45, 1 on root 2. And that's interesting. Yeah, we're going to talk about that later when we talk about the complementary law. And tan 45 is 1 over 1, which is just 1. Okay, let's have a look at how we determine that's 3061. So what I'm going to do is I'm going to draw myself an equilateral triangle. That looks pretty equilateral, it'll do anyway. Now, if this is equilateral, which means this distance, and this distance are all the same, we have to decide on a length. Before you jump in and decide on a length for those, let me just do something here. I'm going to drop an altitude. Now, an altitude is a straight line that hits the base at 90 degrees. That's the definition of an altitude. So imagine I've drawn this line, it hits at 90 degrees. Now, in an equilateral triangle, and we can do this via a proof with geometry, but they're no longer in the syllabus, it splits this base into two. What else do we know? Well, this is an equilateral triangle, so we know all the angles are 60 degrees, 60 and 60 degrees. And the other property of an altitude in an equilateral triangle is that it splits this into two equal parts. So that'll be 30 degrees and that'll be 30 degrees, because remember, it's an equilateral triangle. Now, what length are we going to choose so that we get the simplest ratio? Because this, remember, this can be any size triangle. Well, if I choose 1 here, which I can, that means I'm going to get a half here. I'm going to be dealing with a fraction, and I don't want that. So what I'm going to choose, instead of 1, I'm going to choose this distance to be 2 units. Hence, all the sides are 2, hence that's 1 unit. And now if I just take this part of my triangle and redraw it over here, what have I got? I've got a right angled triangle. And I know this exists because I drew it from an equilateral one with a 90 degrees there because I dropped the altitude, 1 unit there, 2 units there, 60 degrees, 30 degrees. And I can work out this by Pythagoras is 2 squared minus 1 squared, which equals root 3, because 2 squared is 4, 4 minus 1 is 3. And then all of a sudden, you get the ratios for sine 30, cosine 30, tan 30, and sine 60, cosine 60, and tan 60. And they are also given on your formula sheet. What are they? Well, sine 30 is 1 over 2. We already knew that was the first thing we did. Cos 30, root 3 over 2. And tan 30, 1 over root 3. Sine 60, root 3 over 2. Interesting point. 30 and 60 add up to 90, and the ratios are the same. There's a reason for that, and we're going to look at it when we look at the complementary law, which is what that is, two angles that add up to 90. And that's why they called them sine and cosine. Anyway, we'll get onto that later. So cos 60, 1 over 2. And tan 60, root 3 over, I'll now look at that and look at the relationship. There's also a relationship between these two. Okay. So in question 10, they ask you to do that, but they don't tell you where it comes from. And it comes from an equilateral triangle of units 2, 2, 2, where you've dropped an altitude. And I think that's important that you know where that comes from. The rest of these are pretty easy. I'm not going to spend much time. Just remember that when you're rounding these, the halfway point is not 5, it's 30, because you're dealing with 60s. So when you're rounding these to the nearest degree, so if you look at these ones, so if I go here, I'm going to draw a line there. If that is 30 or more, we round up. If it's less than 30, we leave it alone. So that'll be 19 degrees. This one, however, that's a 37. So that's going to round to 77 degrees. You just have to remember that the halfway point, halfway between 1 degree and the next degree, is 30 minutes. And halfway between 1 minute is 30 seconds. So when we're doing these ones, all right, we're going to here and we're going, all right, what is this going to be? Oh, look, let's look behind. Is that 30 or more? Yes, it's 34. So this is going to be 19 degrees and 26 minutes. And if I look at this one, look at that number behind. Is it more than 30 or 30 or more? No, it's not. Oh, sorry, I've gone the wrong one. Let's have a look at this one. If I look behind, and because I'm going to this, is that 30 or more? No, it isn't. So I'm going to leave this one alone, 76 degrees and 37 minutes. To change these to decimals, you just have to use your calculator, and you've got to be able to do your calculator. So I'm just going to do these two very, very quickly and make sure that you can use your calculator for these. So I'll do these last four. So I'll get my calculator up. To change those to a decimal, so I'll just go 83 degrees and I hit my bubble button, 31 minutes, and I hit my bubble button again. We say bubble, but it's the degrees, minutes, seconds button. Don't worry that they've got the same symbol. It doesn't matter. It writes it in degrees, minutes, and seconds, but if I hit the bubble button again, it'll change it to a decimal. And if I hit the bubble button again, it changes it to degrees, minutes, seconds, and so on. So if I type in 73.213, and I hit degrees, minute, I press equals, and then I press degrees, minutes, seconds, 73 degrees, 12 minutes, 46.8 seconds. Once you get into seconds, seconds become decimal again. So if I'm doing tan 54 degrees, 20 minutes, so making sure your calculator's in degrees modes, tan 54 degrees, 20 minutes, you can close the brackets, you don't have to, press equals, and I'm just going to double check that because I'm pretty sure I'm right, but I'm just going to check it. What is it? 15E and 1.393 if I rounded it to 3 decimal places. The last one is if you get an answer, right? So remember, this is an equation, yeah? So to find the value of the pronumeral, oh, is that a pronumeral? Yes, it's a Greek letter. It's theta. Well, we use because they gave it trigonometry. So we go cos to the minus 1, which is the inverse of 0.827. Because it's an equation, we're just undoing it. So I go, now, to get this, I go shift cos, and I get cos to the minus 1, which is, I don't like that symbol, but anyway, 0.827, press equals. 34.2 is the decimal, 34.2 ... But we want it in degrees, minutes, and seconds, so we are very fortunate. We have our bubble button, and it's 34 degrees, 12 minutes, 29.56 seconds. 34 degrees, 12 minutes, 29.54. They only want it in degrees and minutes, so I've got to stop here. Is that 30 or more? No. So I'll leave it alone. 34, and by the way, that's a double dash, 34 degrees, 12 minutes. All right, so you should be right with exercise 501. Please remember where that right angle triangle for 30, 60 comes along. Anyway, good luck.